Welcome to all of you. In the last lecture, we talked about transients in power system, in which we talk about transients phenomenon. Then after we discuss about transient results. Then after we talk about electromagnetic energy, electrostatic energy, and types of system transients. Now that was about the introduction regarding the transients in the power system. So as per the syllabi, we are going to start our first topic, which is the transients in simple circuits. In order to understand the simple circuits, we are going to start first with simple circuits, then after we will go for difficult one. For those, there are some assumptions we are going to make, and other things I want to mention here is that for analyzing the various transients, we will make use of Laplace transform technique, which you may be aware of in your last semesters as you may have studied it, because Laplace transform technique is more powerful and easy to handle the transient problems than the differential equation technique. And the second case, we will assume here lumped impedances only, as I already talked about in last semester about lumped parameters, lumped impedances. Actually, if you will see the resistance or inductance, it is uniformly distributed along the line, but whenever we do calculations, we are always use lumped parameters so as to make our calculations easy and simple. And later what we will do, we will take both the circuits, AC and DC sources, driving R, L, RLC circuits. So let us start with first one, that is resistance only, but here where the driving force is DC sources. First we will take DC source, then after we will take AC. So as this is a simple one, here there is a circuit and we have an element, that is a resistance. We have DC source, that is why it has been plus and minus. If it had been AC, then it had been just like this. So for a resistance circuit, for a resistive circuit only, if you will on the switch here, what is going to happen? There will be flow of current in the circuit, and that flow of current will be given by V by R. As I have mentioned, it is V by R. Now if you can see it in the diagram, it is just there is an abrupt rise, because resistance is not a storage device. It does not oppose the change in current, nor it opposes the change in voltage. As if you talk about inductance and capacitance, they have property of opposing the various quantities, whether it is voltage or current. So that is why it is here. Just when we close the switch, there is a rise in current, and that is the limit of current will be given by resistance in the circuit. So the magnitude of I is V by R. Okay. Now we will take the second circuit. Now in the second circuit, we will talk about inductance, and the driving force is obviously DC, because we are talking about only DC right now. So here is a DC source, here is a switch, and here is your inductance. Now as I have already talked, we are using the Laplace transform technique. So what you will do, we have to calculate the impedance first of this. Okay, here I of S, we are talking about S domain. So I of S will be given by V of S divided by impedance of the circuit, which is ZS, which is, now as this is a DC source, so the Laplace transform of V If it is a DC source, that is V by S, and impedance obviously that is S L. So this is V by L, 1 by S square, S into S, that is 1 by S square. So take here inverse Laplace of this. This is V by L, this is 1 by S square, that is T. So we are converting S domain into time domain. Now if you will see this term is almost constant. So this I t is proportional to t. It means it's a linear function. There is a ramp signal just like this. So at t is equal to 0 plus, just when we close the switch, what it acts as? What it acts as? Anything coming in mind? That acts as open circuit, because if you will see from here, it is at 0 plus it is 0. The value of current is 0, because the inductance has the property of opposing the change in current. That is why there is a gradual rise of current. See here, there is a gradual rise. If you will see this, at t is equal to 0, at t is equal to 0 plus, it is 0. It means inductance has the property of opposing the change in current. There is a gradual increase of current, and the slope is given by V by L, as it has been shown in the diagram. So next we will talk about capacitance. So here is a DC source, here is a switch, and there is a capacitor. Same as it is, just we did it in case of inductance. Here I of S is given by Vs by Zs as the DC source. This is V by S, it is Cs, because Z is here is see 1 by Cs. When we take it, it will come in numerator. This and this will get cancelled. That is Vc, which indicates that what is it? It is an impulse of strength, or you can say magnitude Vc, because impulse function has value only at this point and rest it is 0. You may have studied it in your earlier courses. So let us move to next one, that is RL circuit, or we generally call it as series RL circuit. You may have gone through this in your basic electrical or may network analysis or signals and systems. Let us revise it here again. There is a RL circuit. This is a DC source, this is resistance, and this is inductance. So just you are repeating the same. Here Is is given by Vs by Zs. Now here there are two. The impedance is the combination of R and L. So for V it is V by S, for this it is V by S, and Zs is R plus S L. So again, after what you are doing, what you will do here, you will separate L from S in order to make Laplace inversion. As you have, it is also given in the book which I have recommended, which may you have already seen Vadva. You may go through this as well. You have to just separate this. It means you have to divide by L, then it will get separated. Then after you will take inversion of that, and after that it will come V by R, 1 minus e raised power minus R by L t, which indicates is a rise. How? Listen it carefully. If the differentiation of this comes positive, keep one aside, I am talking about minus e raised power minus R by L t. if the differentiation of this comes positive, then it will be 1 plus this, then it is a rise in any quantity, rise in current. If it is I here, if it is voltage, then it will be rise in voltage. Now if it will come 1 minus, then it is decreasing depending upon the value of this. If suppose we will talk only about this E minus R by L T, if it had not been 1 minus, then it was decreasing, but here it is 1 minus e raised power minus R by L T, so it's a rise in current because it's a current quantity. So now we will talk about tau, which we generally call time constant. Here tau is L by R, which is actually the reciprocal of this. It means what? When this minus R by L T, when this is equal to tau, means it is L by R, it is R by L, it means minus e raised power minus T by tau. So when we put the value of tau as L by R, it will get cancelled, it will be 1 minus e raised power minus 1, which is 1 minus 1 by E, and when we will calculate it, it will come V by R into 0.632 Im. Im is from this V by R. You can write it as I to the base M maximum, or you can just write it as V by R into 0.632, and when we will calculate in percentage, it is 63.2. It means at time T is equal to L by R, the current in the circuit is 63.2% of the maximum value reached in this circuit, which is usually called as time constant. Now, is a point you can note it down as well. I want to mention it here. Now, the larger the value of inductance, this larger the value of inductance as compared to this resistance. I am repeating, more the value of the inductance as compared to resistance, the slower will be the build up of current in this circuit. That will be just like this, just below this, slower, because the more the inductance, more is opposes the change in current. It means higher the value of this as compared to this, slower will be rise in current. Is clear? Now moving to next one, RC circuits. Now here it is a voltage source, it is R, it is C. So just we did in the previous cases, here I of S will be equal to Vs by Zs, impedance of the circuit. That is, from this it will be V by S into 1 divided by R plus, when we calculate in S domain, that is 1 by Cs. I have mentioned it here. After that, just like in the previous cases, you will divide. First you will take common this, then after you will separate your S by dividing by RC, then after you will take inversion, Laplace inversion. After that, the value of IT will be V by R e raised power minus T by RC. It is also, it has been explained in the recommended book as well, you can go through that. So here the value of IT is V by R e raised power minus T by RC. Now, as well as already talking in the previous slide, that if the differentiation of this comes negative, then it is a sign of decreasing. See here, just like this, IT. I have not write it as ICT. It is ICT actually. This I have written it as ICT is actually IT. See here, it is decreasing because if you will differentiate this, it will come minus V by R rest terms. It is decreasing with time, and capacitor is going to charge. We will talk about capacitor. That's like this. Now, if you will see that at t is equal to 0, the capacitor acts as a short circuit to the DC source. Just like at t is equal to 0, just when you close this, the capacitor will act as a short circuit to the DC source, and this current, which is rising current, will be limited by the resistance. It is resistance in the circuit. More the value of resistance, lesser will be the rising current. Lesser is the value of resistance, there will be more rising current. So, is this clear? The next one, we will talk about RLC circuit, in which all the three elements are there. That is resistance, inductance, and capacitance. This is a DC source. This is a switch. This is RLC. Here, I of S, in just like we did, that is V by S, that is 1 divided by R plus SL from this, 1 by CS from this. Just you have to repeat the previous cases. You have to separate. Here it will come S square. It means you have to separate all terms from your S square. When you take this common, it will come S square L C. It means you have to divide it by L C in order to separate S square. Then after solving and by assuming two terms, that R by 2L is equal to A and under root of R square by 4L square minus 1 by LC as B. Then after solving, IT will come as V divided by 2BL e raised power minus A minus B T minus e raised power minus A plus B T. Now, that is the value of resulting current just after closing this switch. Now, there will be three conditions based on the value of B, as I have mentioned it in. When this, the value of R square by 4 L square is greater than this 1 by L C. I am repeating, when the value of this term is greater than this, the B will come real term. I will show it, then we will explain it. Second case, when this term will be equal to this term, under that condition the value of B will come 0. Obviously that is this minus this, that will be 0. And in the third case, when this will be greater than this, value of 1 by LC will be greater than this. In that case, B will come imaginary. How and why these three conditions are going to happen, we are going to discuss it in the next lecture. Thank you, all of you.